This is a quick demonstration video of our new Anchor system using the Android phone to create a VSLAM solution for robotics. I'm first going to show you the process of how you scan the system. So what you do is you take the app and then you scan the environment. You will notice little dots, red dots around. That's just basically the anchor points it's detecting. And what that is going to do is it's going to indicate that if the anchor points it sees is sufficient or not. If it does, it's going to drop an anchor like these little dots. And then what I can do is I can paint by using that button, and I can draw, just tap and draw more area. If you see there's a plate, and I can also delete that path it's kind of like a boundary system where right here, for example, is a little too close to the walls. So I'm going to delete that, maybe not too much. So I'm going to add a little more here. And make sure the robot has a good path. If it doesn't, it might have the wheel run into the wall. So that's basically what this purpose is. But you can also change it in the model itself on how big the base of the robot is. So we have a good redundant going on. So now that they have a path, or I just have to make sure that the path, or we call it the nav mesh, navigational mesh, is sufficient and connected. So therefore the robot can actually find the way to its destination. And that's what I'm doing right here. I'm going to make sure that the path is sufficient, and it looks like it's getting there. Now that it seems like the path is, or I would say the path or the surface that you see in the translucent thing there, you can verify. So mainly just to know that the robots have a good ground understanding where it can go, where it can't go. That's what that translucent is. And those little box cubes things are just basically anchor points to essentially tell the robot where it's at, to reference it using the vision system of the Android. And this is just a old Galaxy S20, and there's that robot. So what I'm going to do is I'm just going to go ahead and install this to the robot. And then I'm going to use the manual controller right here. Right now it's on manual mode, so I have to control it. But now I can actually have it be automatic, and it's going to try to go to a predefined destination. So if I press this button, it's going to be a automatic mode. As you can see here, the robot's starting to navigate, and the green path, just like in the Tesla car, shows you where the robot is thinking about going based on what it sees. And the robot is being controlled by that S20, old S20 smartphone, using the AR core functionality. And this is, I'm not controlling it at all. So now it's getting a little confused about its base. So that's just a minor fine tuning that we can do. So now it's going to go all the way over there. That's where the predefined destination is. So the robot knows exactly where it needs to go. Where the scanning methodology is quite simple, like I showed previously. So the next thing that we're going to need to work on is giving it dynamic vision control, and that's what we plan on using this 3D camera, or one Intel RealSense, and couple with a more powerful Windows x86 system, and that way we can have more logic to it. So now I'm going to control it manually for it to go somewhere else, and then I'm going to have it go on auto mode, and it's going to automatically go to a predefined destination. Not so much. Well, let's see what it sees. Oh, that's why. I need to make a better mount for this. It kind of fell off. But so that's the progress so far of automated system using really low cost hardware that's off the shelf. And thanks for watching. Here we go. Now it knows where it goes. It helps to not have your eyes knocked out of the socket. There it is.